7, section 11, exercise 6. We're asked to find what is our um, series using our results from exercise 9.9 that I rewrote here. So one thing I want to start by doing already is finding the f of x, absolute value power 2, which is then going to be equals to the integral of starting from -1/2 because of this to 1/2, so over here. What is f of x? F of x is x squared, so squared is going to be equals to x to the power 4 dx, so I get 1 over 5 times x to the power 5, starting from -1/2 to 1/2. Okay, so if I plug it in the calculator, I obtain, give me a second to do it, 1 over 2 power 5 minus, you get -1 over 2 the power of 5. So it's about 1 over 1 over 80. It's perfectly 1 over 80. Okay, so this is already my f of x squared. And now I can look at this equation over here, and I see that this thing is equals to a naught, of course, and this thing is equals to that a of n. So a naught is already there, and a of n is equals to what? Well, a of n is equals then to, we'll start by running the constant in front, 1 over pi squared, and then the sum of, starting from n equals to 1 to infinity, of what? Well, we're going to have 1 over n squared, but given by these values over here, and then cosine, of course, of 2n pi x. And then, since we see that the sign changes every time, we have to do times 1, -1 at the power of n plus 1. Okay. So, and then we find that a of n, the power of 2, is then equals to 1 over pi squared. We can ignore the sum now and rewrite as 1 over n power of 4. Oh, sorry, the power of 4 again. Then this cosine just disappears because we're going to find the average. So it's going to be equals to 1. And then we get -1 times 2n plus 2. As you can see, this value over here is always even. Therefore, this value over here is always going to be equals to 1. So we can erase it, and we can rewrite a of n squared is equals to -1 over pi over 4. Also, it's going to be a positive because this negative here, of course, is squared. So 1 over pi over 4 times n to the power of 4. Okay, so now we put all together. So we're going to have to put f of x, so value squared, is equals to a, a naught squared plus 1/2 of our function a of n squared from n equals to 1 to infinity. So now this left side is equals to 1 over 80. Then the left side is going to be equals to, well, 1 a naught is equals to 1 over 12, we said. So square is going to be equals to 1 over 144 plus 1 over 2, and then sum of n equals to 1 infinity of a of n. So it's going to be equals to, well, like we just did here. So we're going to do 1 over 80 minus 1 over 144, everything times 2, equals to the sum, n equals to 1 to infinity of 1 over pi over 4 and n over 4. Then we can multiply both sides by pi over 4. So we're going to have pi over 4 on this side. We can cancel on this side. And as you can see, we already got our answer because on the right we get that it's a sum of n equals to 1 to infinity 1 over n to the power of 4. And as you can see, it's exactly what we were asked to find at the beginning of the problem. So our answer is going to be equals to, well, let's simplify this. We're going to get that is equals to pi power of 4 times 1 over 40 minus 1 over 72, which is equals to 1 over 40 minus 1 over 72, is about 1 over 90. So we're going to have pi over 4 over 90 is equals to the sum from n equals to 1 to infinity of 1 over n to the power of 4. And that is our final solution.